4096. The primary cause of all changes in the Earth's weather is A. Variation of solar energy received by the Earth's regions. B. Changes in air pressure over the Earth's surface. C. Movement of the air masses. The correct answer is A. Every physical process. 4095. How much colder than standard temperature is the forecast temperature at 9,000 feet, as indicated in the following excerpt from the winds and temperature aloft forecast? A. 3 degrees Celsius. B. 10 degrees Celsius. C. 7 degrees Celsius. The correct answer is C. According to the winds and temperatures aloft forecast, the temperature is minus 10 degrees Celsius at 9,000 feet. Using the average lapse rate of 2 degrees Celsius per 1,000 feet, the temperature change from sea level to 9,000 feet is 18 degrees Celsius. Standard sea level temperature is 15 degrees Celsius. Subtract 18 degrees Celsius from 15 degrees Celsius to get minus 3 degrees Celsius. Compared to the forecast temperature of minus 10 degrees Celsius, the difference is 7 degrees Celsius. 4113. If the air temperature is plus 8 degrees Celsius at an elevation of 1,350 feet and a standard, average, temperature lapse rate exists, what will be the approximate freezing level? A. 3,350 feet MSL. B. 5,350 feet MSL. C. 9,350 feet MSL. The correct answer is B. To determine the approximate freezing level, we need to consider the standard temperature lapse rate. The standard temperature lapse rate is an average rate at which temperature decreases with increasing altitude in the troposphere, which is approximately 2 degrees Celsius per 1,000 feet, or 3.5 degrees Fahrenheit per 1,000 feet. Given that the air temperature is plus 8 degrees Celsius at an elevation of 1,350 feet, we can estimate the freezing level by calculating the altitude at which the temperature would drop to or below 0 degrees Celsius, using the standard temperature lapse rate of 2 degrees Celsius per 1,000 feet. We can estimate the temperature change over 1,350 feet. 1,350 feet by 1,000 feet equals 1.35, approximately. 1.35 multiplied by 2 degrees Celsius equals 2.7 degrees Celsius since the initial temperature is plus 8 degrees Celsius. Subtracting 2.7 degrees Celsius will give us an approximate temperature of plus 5.3 degrees Celsius. Therefore, based on this estimate, the approximate freezing level would be around 5,350 feet MSL, mean sea level. So, the correct answer is B, 5,350 feet MSL. 4094. A common type of ground or surface-based temperature inversion is that which is produced by A. Warm air being lifted rapidly aloft in the vicinity of mountainous terrain. B. The movement of colder air over warm air, or the movement of warm air under cold air. C. Ground radiation on clear, cool nights when the wind is light. The correct answer is C. Ground radiation on clear, cool nights when the wind is light. A common type of ground or surface-based temperature inversion occurs due to ground radiation during calm and clear nights. When the Earth's surface cools after sunset, it emits long-wave radiation into the atmosphere. Under calm conditions, with light or no wind, this radiational cooling can lead to a decrease in temperature near the ground. As the ground cools, the air in direct contact with the surface also cools. This cooler air, which is denser, remains near the surface and forms a stable layer. Meanwhile, the air above this layer may be warmer, creating a temperature inversion where the temperature increases with height instead of the usual decrease. This inversion layer can trap pollutants or fog beneath it, leading to poor air quality or restricted visibility. 4112. The most frequent type of ground or surface-based temperature inversion is that produced by A. Radiation on a clear, relatively still night. B. warm air being lifted rapidly aloft in the vicinity of mountainous terrain. C. The movement of colder air under warm air, or the movement of warm air over cold air. The correct answer is A. The most frequent type of ground or surface-based temperature inversion is typically produced by radiation on a clear, relatively still night. Option A correctly identifies the most common cause of ground-based temperature inversions. During clear nights with little wind or air movement, the Earth's surface cools down through radiation. As the surface cools, the air in contact with it also cools, resulting in a stable layer of cooler air near the ground. This stable layer forms an inversion where temperature increases with height instead of the usual decrease. It acts as a barrier that prevents the vertical mixing of air, trapping pollutants and moisture beneath it. This type of inversion is commonly referred to as a radiation inversion or nocturnal inversion.